When people say that they don't like science, to me, that's like somebody saying they don't like music. Most people like some kind of music or other, but it would be weird to say they just hate music. And to me, that's what saying somebody doesn't like science is, because there are so many different kinds of science. There are so many different forms, styles, approaches. I think everybody likes science. They just have to figure out what kind of science they like. We are responsible for ensuring that people can understand and engage with science. The effects of not taking ownership of that role are living with us now. I think acknowledging that communicating involves more than one person, and that if the other person does not understand, that does not make them wrong. That means you need to adjust.
Welcome to the Science with Impact podcast. Here we provide resources for research scientists looking to broaden their societal impacts, and we have a stellar guest for you. Jocelyn, would you be willing to introduce yourself?
I'm Jocelyn Bosley, and I wear a number of hats at the University of Nebraska-Lincoln. My main gig is the Research Impact Coordinator. I came to this role implementing broader impacts activities, and one of those is a website called Fun Size Physics that I serve as the curator for. So I'm also a director of education partnerships on a newly funded NSF Global Center on food innovation and diversification to support the bioeconomy.
Why should our listeners, who are predominantly research scientists looking to broaden their societal impacts, listen to our conversation today?
I think it will hopefully open their eyes about what broader impacts can do, not only for the audiences that they're trying to reach, but also for themselves. I think it helps them get back in touch with maybe what made them fall in love with the field to begin with. And a lot of times research is frustrating and the equipment breaks, but there are all these challenges, other pressures, external pressures as well, that everybody's facing right now in research. Focusing on sharing your work in ways that will be meaningful to others is oftentimes a way to reconnect with what you love most about your work and kind of help you rediscover that. And it's also a critical skill to be able to communicate that. We're seeing what happens in society when a large part of the population does not understand how scientific research benefits them. Even those who maybe didn't see the value of it earlier are now seeing, oh, well, I'm very invested in having a society that values and funds science, so I need to do my part to help make that happen.
How did you hear about Science with Impact?
I saw you speak at an Eris webinar. I hope that lots of your regular listeners and viewers already know about Eris, but I'll put in a little plug anyway. I know you recorded an episode with Janice McDonald, who is a co-PI on that project, and she's amazing. So after you're done watching or listening to this, people, go watch that one if you haven't already. But wait till you're done with this one first. Eris is the Center for Advancing Research Impact in Society, and it's actually an NSF-funded center. I have been part of the Eris community since I actually started this role. So I started as Research Impact Coordinator in 2020, and UNL was invited to participate in the pilot cohort of their program to enhance organizational research impact capacity. But it's basically about the trainer model, helping impact professionals really provide the kind of support and training for their faculty that hasn't really existed on campuses prior to Eris kind of creating this program to help institutions enhance their capacity. Our participation in that cohort coincided with my starting the position. So it was really kind of my onboarding, really. And so I've continued to be super grateful for the Eris community and very engaged with it. What especially appealed to me about the panel that you were on and hearing you speak on the panel was that you had this model for calculating impact that was based on physical principles. Since I also sort of straddle these two worlds of research impact professional and working in physics education, and I love metaphors, I was amazed that it hadn't occurred to me to say, hey, how is impact calculated in the physics context? And how could we translate that to impact in the societal sense, in the broader impact sense? It was such a brilliant that seemed like it should be obvious to me, but wasn't until after you thought of it and presented it. And I just immediately knew that we needed to be best friends. And here we are.
Best friends, I love that. Here is the framework if anybody's curious about it. I'm showing it on the screen for those of us who are listening today, and we'll be sure to link it in the description along with all the other resources we share today. What impactful moments led to you becoming a scientist?
I hosted a podcast myself a few years ago, and it was called Science Exclamation Point with Friends. And one of the questions that we always asked was, what's your earliest memory of being interested in science? I would say math was actually kind of my first love in the STEM space. And I vividly remember I was in first grade, and we were doing tangrams. So tangrams, there's like, I think it's a standard set of shapes, and there's like squares and triangles of different sizes, different types of triangles, and they fit together to make a square. But then you can also fit them together to make different shapes. So basically, you'll get like a template, and sometimes it looks like a kangaroo, or sometimes it's just like an abstract shape, and you have to figure out how to rearrange the shapes to make that new shape. And it was fun for me at this young age because we could work independently on it. So we'd go and we'd solve a puzzle and then be like, okay, I'm ready for the next one, and trade it in. And I remember having what I would later in Psychology 101 learn it was called a peak experience. And in fact, I was having so much fun that I started singing to myself, and I didn't realize I was singing to myself. And my wonderful, very kind teacher was losing patience, but she also didn't know who it was. She was like, "Who's doing all the mumbling?" And every time she said this, I'd look around and go like, "I don't know who's mumbling, but they better cut it out because they're gonna get in trouble." And then at some point, I was so horrified to realize, oh, it's me. But such was my joy that it just could not be contained. Math would always hit me as like a giant game. It wasn't the practical aspects of math that appealed to me. This will be a theme throughout our conversation. The practical aspects are important, but they're not necessarily what immediately reels me in. It's more like the wonder and awe of things that kind of hits me and gets me engaged. It was really that aspect of math. The problem solving, it's like a game that just keeps on going and going. And then science sort of came along because it was like, well, what can you do with math? You can apply it in all sorts of different ways to science, and then that opens up whole other worlds. I was in high school when I learned about how imaginary numbers were made up mathematically at the time in order to maintain consistency. So in order for it to be consistent with itself, we create these things called imaginary numbers, but then they turn out to be instrumental in describing quantum physics. That was amazing to me that something purely mathematical at the time of its invention then shows up in these natural contexts. And in fact, you need it to explain the actual phenomena of reality. That kind of thing just really hooked me.
I have never heard of peak experience. Can you tell me more about that?
I believe it was Abraham Maslow who coined this term, kind of a euphoric feeling. And just feeling like all is right with the world. And I just feel elated and happy and perfect in this moment right now. I think might be how he would describe it. And that's certainly how I felt doing tangrams.
What do you think it was about doing tangrams that made you feel that way?
I love a challenge. I never understand when people want to just like skip to the end of something or look ahead to the answer. In fact, I worked with middle school students for a while. I was a mentor of highly gifted students in math and science at middle school, and kind of tried to instill that in them too, just by example. Like sometimes they'd be doing a tough problem, and it would be one that I had created out of my head, or maybe a really challenging one that I had found. And it was very seldom a problem to which I already knew the answer. It was interesting to watch this sort of gestalt shift in their mind when they realized they would be like, wait, you don't know the answer either? And it was sort of a mixture of like terror and delight. Like they couldn't decide whether this was amazing or scary or probably a combination of both. But my answer was like, no, if I knew the answer, it's not like I'm over here like hoarding answers to hide them from you. I too am trying to figure this out.
Can you think of anything that instilled that or helped to develop a human being who loves challenges the way that you did?
My mom and I have super close relationship and always have, and I love looking at pictures of like me when I was like 1 and 2, because it's very clear that even though I do not have an expansive vocabulary yet, that we are engrossed in deep conversation. No matter how little I am, it's very clear that we are deeply in conversation about whatever was important to me at the time. Having that person, that parent who was not only an example of really being persevering in the face of uncertainty and challenges, but also really supported me in doing that. I think oftentimes, and having worked with highly gifted students, I can say they have not experienced failure that much, perhaps even more devastating to them when it happens. And of course, it happens because we all fail at things. And by fail, I don't mean get an F necessarily. I just mean like don't immediately see the solution to something. Not having had experience doing that, they would get frustrated easily and didn't necessarily know how to move from not understanding to understanding. They didn't have that sense of like, well, okay, let's just try something. What does that mean? Write something down. Let's make a list of the things we know, that kind of thing. And I think my mom not only modeled that for me a lot, but also was just so supportive that I always felt like I was unconditionally loved and accepted, even if things didn't go the way I wanted them to. The pressure was just to do my very best always.
That love and support created a safe space for you to pursue challenges the way you do. I love a challenge, and from a young age, I was also very much drawn to challenges, but I think it was out of pursuit of trying to find that love and acceptance. I've had to learn how to feel like I'm enough and how to not constantly look to overperform and over excel for some perceived need for affection and attention. And so I'm just so happy for you that you've discovered this love for a challenge in a healthy and a non-toxic way. Have you heard of the marshmallow experiment?
Oh, yeah.
Yeah. Okay, so for anyone who's listening who doesn't know, there is this series of experiments that scientists have done with children where they're basically measuring the child's comfort with delayed gratification, their patience with waiting to get a reward. And so what they'll do is that they'll put a marshmallow in front of a child and say, "You can eat that one, but if you wait, you get two." And then they leave the room. And often the child will see them leave the room and then eat the marshmallow. But there are some rare children who will wait and get the second marshmallow or more marshmallows. I just imagine, Jocelyn, that you would have all the marshmallows.
It's not because
Okay.
I'm necessarily so great at delay of gratification, but the other thing about that experiment that they've talked about is that it can vary a lot by socioeconomic class, background, and things like that. Because, of course, children who are living in a food insecure kind of environment might be the smart choice for them, might be to eat that marshmallow while it's here, because you don't know. Somebody said there might be two later, but is that
Mhm.
really going to happen? We don't know. And so it tends to be children who do have that sense of security and stability who are then in the better position to say, okay, well, then I will wait. And I definitely had that.
It's an interesting experiment to even just a thought experiment of thinking, how do you think a little version of you would pursue this? I'd love to see in the comments somebody talk about that. You clearly have a fascinating background spanning multiple disciplines, including math, physics, chemistry, biology, English, and gender studies, and I think also a lot of psychology, which is really interesting. How does this sort of interdisciplinary perspective inform your research for impact in science communication?
I have talked a lot, and I think this is why I enjoyed working with middle school students because they are at a sort of critical stage where they are capable of grasping some pretty sophisticated ideas and concepts, but they also have not pigeonholed themselves yet into saying, like, oh, I'm a math person, and that means I'm not a writing person, or I'm an art person, which means I'm not a science person. They move very fluidly and make these connections. That's what I absolutely thrive on. I really love most about the research impact space too, is that you get to do that. You get to connect seemingly disparate ideas, you get to connect people, you get to connect people with ideas, and making those connections, the more acted, the better, is something that I really enjoy. And in fact, my diverse background is partly a function of my commitment issues. It took me 7 years to get through undergrad, not because I didn't have enough credits, but just because I was like, but there's things I want to do. And part of it was realizing, and I think more students now get this, which is good, that you don't have to necessarily decide in college what you want to do for the rest of your life. You can decide what you want to do next because the world is going to change anyway and new opportunities are going to open up. So you don't necessarily have to find the thing that's going to be your thing forever. That was sort of some undue pressure I put on myself. I worked in a physics lab as an undergraduate researcher. I worked in a genetics sorting fruit flies by eye color with a little paintbrush. And the further I got along any of those paths, I realized that it's the connections to other fields that really interest me. I kept thinking maybe if I just find the right field in science, that will fix the problem. And so it was biophysics. It remains near and dear to my heart. And on the Fun Size Physics website, I love it when we get to feature biophysics posts. That was what I thought I might go into because at least that would give me a way to integrate my different scientific interests. I went to visit biophysics program at Penn and stayed with a friend of mine who was then getting his graduate degrees in the history and sociology of science at Penn. When I heard history of science, I didn't fully appreciate what the history of science could be and could mean until I was staying with him and talking with him about his actual research. Then I started going, oh, these might be my people. This is integrating all of my different interests and not only kind of integrating them, but really actively probing those connections that I get so excited about. I started sneaking off on the sly while I was supposed to be there visiting the biophysics program. I started sneaking off to visit the history of science people. And by the end of it, I was pretty convinced that that was what I wanted to do. So it's good that my mom was so patient and tolerant and did not force me to make a decision prior to my third senior year about what I was going to do, because it would have been the wrong choice. I realized at that point it wasn't a matter of which area in science, it was that the way scientific research is structured and the way you specialize, which is a very good thing and a necessary thing for the progress of science, but it didn't play to my strengths and interests, because my strengths and interests were about these sort of macro level connections, not only within, but between science and society as well. And so the history of science really let me do that.
My journey into more science communication is similar, where I love chemistry and medicine and biochemistry and pharmaceutical chemistry. And I really like graphic design. And it's really interesting for me to combine those two. And recently, it's been a lot of 3D molecular animation and combining that and just the love of it all, teaching chemistry and finding ways to engage with people about psychology and thinking about how they learn. I can really relate to that. I think that's what has led me into a career of more informal science communication, more industry applications of research, professional development for graduate students, and finding ways to broaden participation in STEM. Those are kind of the big areas for broader impacts. I think it just makes sense that we found the careers that we found because we're more wired to look at the connections of things rather than one aspect of the discipline, which is also valid.
Absolutely. And we need people who think that way too, but we also need the people with the bigger picture to connect them with each other. Honestly, even when I was really thinking I'm going to have a career in science, the research itself was my least favorite part of it. The fun part for me was getting to talk with really cool, interesting people about really cool, interesting ideas.
We've talked about your fun size physics project, and I feel like this is a really great way to highlight your interdisciplinary expertise. Can you tell us about fun size physics?
The website was born on Leap Day 2016. It's actually been around for almost 10 years now. Shireen Aidenwala is the PI on the project. She's a professor in the UNL physics department and my favorite co-conspirator. As she tells the story of the origin of fun size physics, there was session at the American Physical Society talking about the image problem that condensed matter physics has. As she tells the story, she was a little bit too vocal during that session and thus found herself leading the effort, as we tend to do sometimes when we open our mouths. She was happy to do it and is great at it and has great instincts for science communication. I was starting at the university right about the same time that this project was in the works. I actually started at UNL as the education and outreach coordinator for our NSF funded MRSEC, Materials Research Science and Engineering Center. Shireen was a faculty member in the MRSEC and she was also working on launching this fun size physics project. And so the timing was good. And so that became another part of my role. In addition to working with the MRSEC, I also worked on fun size physics, and I still do to this day. To go back to the image problem that condensed matter physics has, for the non-physics folks in the audience, there are three major areas of physics research, and one of them is high energy physics. You may know high energy physics from things like strange quarks, charm quarks, the Higgs boson, all very kind of sexy, exciting sounding things. It made big international news, obviously, when the Higgs boson was discovered, made its way into pop culture. Lots of people got excited about that. Astrophysics, I guess, is another sort of field that encompasses aspects of both high energy and the next area of physics that I'm about to say, which is atomic, molecular, and optical physics. That's another area of physics that the public might get kind of excited about because it's like all about these like amazing lasers that are doing amazing things. Condensed matter physics. What does condensed matter physics have? Well, it has semiconductors, so that's good and all, but I think that there are other people like me who don't actually value a thing necessarily based solely or even primarily on its practical utility. Because condensed matter physics, which is closely related to materials physics or materials science, nanoscience might be another word. There's subtle distinctions between these, but they're all kind of in the same general area. I think that It's really utilitarian, and that's kind of how it's been perceived. It makes your smartphone work great. I personally don't feel that compelled to find out how my smartphone works. That's not what makes me value something. The reason biophysics appeals to me probably is that I'm like, what even is life? Or like in the physics space, what is time? These were the big questions that kind of preoccupied me. Sort of the bordering on the philosophical, but like how do we answer these within the scope of mathematics and physical principles and all that. So when I was an undergrad, I actually was not very excited about condensed matter physics. It was the least interesting to me. And I only ended up doing research in a condensed matter physics lab because of the amazing Peter Daubin. He's a legend. I had come out of high school thinking that I didn't really like physics. And it was because my high school physics teacher very much took the approach of like, here's a packet of equations, memorize them, and then take a test where you plug the numbers into them. I'm very much a why person. Why am I doing it this way? I also kind of made this joke in college when I had a friend that I would always do physics homework with, and he was an engineer, and I was a physicist or physics major at the time, but it was definitely coming at it more from the physicist perspective, and he was basically thinking as an engineer. If he could find an equation or a formula that gave him the answer in the back of the book, he was happy. He was like, okay, that problem's done. And I'd be like, why is it that formula and not this one? And he would be like, who cares? It's right. And I'm like, I don't care. I care deeply. And so I think that was part of why I did not find my high school physics class very rewarding, is that it was just like, okay, here's the equations, no context, no explanation of why. When I got to UNL and took calculus-based physics, the calculus derivations of the formulas that helped in and of itself, but also having Peter Daubin as an instructor. He was just amazing, hilarious, very energetic, talked to undergraduates as though we were peers and perfectly capable of understanding what he was saying, yet explained things very clearly and comprehensively. Basically, he saved physics for me because I came in thinking I didn't like physics. I wanted to work in his lab, and he was a condensed matter physicist. And so that was really how I got into that particular subfield. I think otherwise, my perception of it was like, okay, it's like making semiconductor chips. And that does not sound nearly as exciting to me as things like quarks and the makeup of an atom and how these things work. I could easily have gone a different way with my interest in physics, but it shows the importance of having really good quality mentors and role models. Because of Peter Daubin, I decided to take a chance on condensed matter physics. And what I found out, of course, is that there's much more to it than the practical utilitarian applications. As an impact professional, I don't want to discount the importance of practical utilitarian applications. We care about those too. But one of the things we can talk about is that impact can look a lot of different ways. I think like poetry can have a huge impact on me. I write poetry about physics, and it's one of my favorite things to do because it really helps me capture like the awe and wonder that physics inspires for me. And there are lots of different ways that things can have an impact. And I think what I failed to appreciate earlier about condensed matter physics is that when you get stuff really close together, weird stuff starts to happen. So I always make the analogy to like magnets. If you had four magnets and they were each in different corners of the room, that's not very interesting. But if you get them close together, that's when interesting things start to happen. And it's the same with atoms. When they're packed into a really close space, weird stuff starts happening. And that was really what got me hooked on condensed matter physics was, this weirdness of like almost reinventing matter from within and all the interesting phenomena like superfluidity and superconductors and quantum vortices and things like that can happen. That's the thing we really try to highlight on Fun Size Physics too, is not just the potential for practical applications of condensed matter physics, but really the beauty, and we try to use really beautiful images to kind of convey, and the wonder that condensed matter physics also can provide. So that way there's a little bit of something for everybody.
It sounds like a wonderful project where they can bring together these advancements in fairly complex ideas in physics and bring it to be more accessible to people of all ages. In that process of condensing not just matter, but that knowledge, what are some of the key lessons that you've learned about effectively translating complex science research into accessible and engaging learning materials?
I think that one of the first things we learned is that there is no such thing as a general audience. Or if there is, people have vastly different ideas of what that general audience can be expected to know and understand. Very early in the process, we found out we were going to need to give them a more concrete kind of example or litmus test. What we found, and I think this goes along with like what we know about general science literacy, although in my case, it was just based on my recent experiences mentoring middle school students. And having a hard time sometimes finding sources that were the right balance for them of like challenging and providing enough detail, but not just overwhelmingly technical. The things either tended to be really rudimentary or really technical. So we try to find a middle balance and tell our contributors to write it so that a bright, interested middle school student could understand most of it. If you're doing that, you don't miss the mark too far for the adult science curious but not science expert public either. And it has the advantage of being very concrete, and like the researchers who are contributing content to the site immediately go, "Oh, okay, now I know what you mean. Now I know what you want." It helps them kind of imagine having this audience. It helps them to have that as sort of the litmus test for the scope and level of what they're writing. Another much more recent tip that we found out, we have one person on our team who I call Chat GPT Whisperer. So he was sort of an early adopter. And it's interesting, you would not think that tone, which seems like a very personal aspect of writing, would be something that AI would excel in. But actually does. What we found is that researchers also kind of struggle with that informal. Some of them love being able to use we, you, and exclamation points and things that are in a lot of academic writing. So some of them embrace that easily and love it. But others, I think, even though they think they're writing it in a more casual way for a different audience, it's hard to break out of those kind of molds that we have so internalized about how to write and talk about science. ChatGPT is actually kind of amazing that way, where you can like put something in and say, write this at a middle school level or something like that. And then it spits it out and all the usual caveats about how you still have to check for accuracy and all that. But it can be really good at capturing that sort of more informal tone as well as helping you calibrate the level.
It's really interesting. And so it sounds like two big takeaways are defining your audience in a meaningful way, in a way where you can kind of close your eyes and picture who they are and what they look like and what they're interested in. And then also to leverage AI to help with the barriers in translating our work beyond what we're used to doing and into the realm of what would be useful for that audience member. Is that a good summary?
Absolutely. One other thing that I might add here, well, I love metaphors,
Yeah.
so that's something I think that physicists are really pretty good at. This is the discipline that gave us Schrodinger's cat and lots of interesting kind of thought experiments. Physicists are pretty good at embracing metaphor, so just encouraging them to lean into that the same way they would if they were teaching a class, I think is helpful. But the other thing that I like to talk a lot about is the distinction between accuracy and precision. And the way I think of it is that precision is like telling the whole truth, everything that you know about this subject. And accuracy is you're still telling only the truth. You're not introducing any falsehoods, but you don't need to provide it in as much detail. So there's an XKCD comic strip that I often use to illustrate this. There's a young stick figure asking a question of two adult stick figures about why the sky is blue. And one of them responds, because air is blue. And the other one is like, no, no, no. And wants to get into Rayleigh scattering and all of these things. The first one says, well, I mean, yeah, there's a quantum explanation for every color, but that doesn't mean that you need to get into it right away. And so, I mean, the sky is blue because air is blue, the same way that anything is any color. And so that's a good example for me of explanation that is accurate, but perhaps not as precise as the quantum explanation. And then the punchline really comes at the end when small stick figure at how planes stay up, and the adult says tiny birds in the wings, thousands flapping hard, and the other stick figure is about to have a coronary, of course, at this. Now that would be an example of an inaccurate explanation. The tiny birds in the wings, inaccurate. Air is blue, merely imprecise. And so I think encouraging researchers to understand that distinction and realize that they may need to sacrifice precision in their explanations in order to maximize understanding and meaning in their audience. Because if you explain it in full, precise detail, it may satisfy you, but you've communicated essentially nothing to your audience if they can't follow all of those details. If you want to maximize your message, then you figure out where you can subtract details. But I'm very adamant that that can all still be done while maintaining accuracy. You just might have to sacrifice precision.
That seems to connect with choosing your audience. Is your audience you? Or is it someone else catering the information to that person? Because while it might satisfy you and providing the full explanation, it could very easily overwhelm someone else who doesn't spend their entire career thinking about this thing.
There's another XKCD
Yeah.
that I love, which is, oh, I can't remember exactly how this goes, but it's like, someone on the internet is wrong, or people always misunderstand me. And then the punchline is someone else saying to this person, sounds like you're great at communicating, an activity that famously involves only one person. Exactly what you were saying. Is your audience you? In which case, knock yourself out, but maybe your audience should be someone other than you. Because communicating typically involves more than one person, and your goals in communicating typically are not just about yourself. So I think this highlights, if someone doesn't understand your explanation, you can't say that they're wrong for not understanding it. I mean, yeah, maybe they could have listened more closely, but also maybe there are things that you could have done to help them listen more closely. Ultimately, we are responsible, and we're seeing it now, the way in which we are responsible for ensuring that people can understand and engage with science. The effects of not taking ownership of that role are living with us now and maybe for a while. So I think acknowledging that communicating involves more than one person, and that if the other person does not understand, that does not make them wrong. That means you need to adjust and kind of amplify and tune your signal. Here's another kind of sciencey metaphor, thinking about a feedback loop in a circuit.
What are some ways that researchers are good at communicating with different audiences? And what are some ways that we could be better?
Explaining your work in as many different contexts and with as many different people as possible. And then listening to their questions and their concerns and their feedback is super critical. And I think it helps researchers actually, because you might see your research in a slightly different way as you see it from multiple perspectives. I think that being just adaptable and flexible and being able to come at the topic from multiple ways is super helpful, not only for tuning your message to different audiences, but also just for yourself. We've all had that professor, and I feel like it was usually a science professor in college who, if someone raised their hand and said, I don't understand why XYZ, would just repeat the same explanation again, slower and louder. And I was like, this is not going to help. Like, can you come at it from a different direction? So I think both in teaching and in communicating and outreach, but also in research, being able to come at a phenomenon from different angles and perspectives is super helpful. That's a skill that researchers have in their research. If they could think about approaching communicating about their research in the same way as sort of an experiment and something where you learn to adapt, change strategies based on the results, take a scientific approach, a very experimentalist approach to communicating. I think that would be great because they have that skill set, but they just don't always apply it in the context of communicating about their work. One more thing I might add about how we could be better. I think a lot about different ways of defining objectivity and how we have come to conflate those over time. So there's a sense of objectivity in which it is eliminating biases from our scientific inquiry. And that is definitely to be encouraged, even as we acknowledge that it is not anything that we can ever do completely, because we're trapped inside our own knowledge systems. And so we can't always see what's right in front of our face. We can't always see the ways in which we're limited, which is why having as many different perspectives as possible is a great thing. But I encourage that form of objectivity as an ideal, even though we know we will never kind of live up to it 100% in actuality. But there are other meanings of objectivity. One, I think, kind of assumes that in order to be objective, science has to exist in a vacuum, free from societal values. And like our entire profession, thinking about the impact of science, really showcases that not only does science not need to be completely insulated from the rest of society, not only can it not be completely insulated from the rest of society? I talk about the rate at which we were able to develop the COVID vaccines because there had been all of this research that had been being done previously on coronaviruses, including this was when we were still doing the Science with Friends podcast. We interviewed Lexi Walls, who was then a postdoc at the University of Washington, I think, and she had defended her dissertation in December 2019 on coronavirus spike protein structure. At that time, her project was considered basic research, and it got real applied real fast. So that's one of many examples that I use to support the idea of basic research, even though I kind of hate that term and the distinction because it's a false distinction between basic and applied. But I think the idea that science shouldn't be anticipating or responding to outside values and societal systems is just wrong. We need to be able to respond to our human condition basically, and the problems that face us and the values that we hold. Of course, whose values is a question to ask, and that's again why it's important we have lots of different voices in the room. But I think that sense of objectivity is not something that we need to adhere to. And then the other one that I wanted to highlight is there's a sort of a tendency to conflate objectivity with dispassionate disinterest, kind of stoicism almost. And I think that has not served us well, kind of pretending to be not excited about the stuff we're excited about. Honestly, if we're excited about the science, then we should showcase that and we should talk to people and we should not censor ourselves. We should leave the exclamation points in our emails. We should feel free to let that kind of emotional investment shut through. And I think that's a way to really connect with people.
I've enjoyed our conversation so much, Jocelyn. For our listeners, they know the drill. We have a closing ceremony where our past guest gets to ask a question of our current guest, and so on. And so last time on the podcast, we had the pleasure of hearing from Dr. Matt Wilkins, the founder of Galactic Polymath, also a friend of Jocelyn's. Also, Jocelyn nominated Matt to be on the podcast. So if you didn't know you could do that, that link is in our description. How do you know Matt, Jocelyn?
Matt is actually the founder of the No Coast SciComm Conference, which I have co-chaired for the last several years. So at the time that he launched it, it was, I think, just called like the SciComm Symposium. And it was when he was a postdoc at UNL in the School of Biological Sciences. His particular postdoctoral fellowship was to organize a symposium on an interdisciplinary topic. And I think people who had been in his position previously had chosen things that were still very much like scientific topics. They were technically interdisciplinary, but still very much like of interest to experts in particular scientific fields, population biology and ecology and things like that. Matt decided that he wanted his symposium to be about science communication. And there's actually another story that involved me missing my usual bus and getting a different bus instead and overhearing a conversation with a chemistry professor about psych, which is how I roundabout way got connected with Matt. And after that initial symposium that he organized, then there was a lot of interest and desire on campus to kind of maintain and grow what he had started. And so he was still at UNL the next year. And so we put something on by committee. And then after that, he left for another postdoc at Vanderbilt. And the rest of us wanted it to continue on. We settled into a biennial rhythm now. We, at one time, were going to alternate hosting duties with Kansas State. And that was right around the pandemic. So it kind of fell apart. There were some institutional changes there. But now we host it every other year. And then in the off year, we host a one-day symposium that is kind of a deeper dive into one of the topics raised at the previous.
I would be very curious to know, what do you feel is the greatest impact that you've had through any of your projects? And what was the most fulfilling? And are they the same thing?
I was lucky enough to be selected as one of the 125 ambassadors funded by the Lyda Hill Philanthropies and organized by American Association for the Advancement of Science to provide role models for particularly middle school girls in STEM. There have been lots of opportunities that came about as a result of that, including a couple of different funding opportunities. There was a mini grant that I got. Took excerpts from some of the podcast episodes that I had recorded on Science with Friends, and an animator at UNL, Kurt Bright, who's amazing, turned me into a rainbow science unicorn, thus fulfilling a lifelong dream I never knew I'd had, but immediately was like, yes, this is the pinnacle. And so there was an animated series, and it was called Verbing Science. Verbing Science was inspired by an observation by Calvin of Calvin and Hobbes that verbing weirds language. And it sort of was my answer to what people typically talk about the process of science, at least in secondary science classrooms, is the scientific method. Not that all methods are scientific. There are lots of unscientific methods. There are certain attributes that methods are scientific have in common, but I think it does a great disservice both to science as it currently exists and to the future of science in terms of who finds themselves interested in and can see themselves in science, to pretend that all scientists do exactly the same thing in the same order all the time. As somebody who has had commitment issues and worked in a lot of different areas of science, I, of course, knew that this was not the case. And as a historian of science, studying the way science works, I think the strength of science is exactly in the fact that there is no unitary, monolithic scientific method. What's really exciting to see and how science progresses over time is multiple lines of inquiry and multiple strategies converging onto a solution. And that's when you get really powerful evidence that you're onto something. Talking earlier about how cool it was to me and how it really captured my imagination that imaginary numbers were sort of invented for one reason and then turned out to be super useful in other ways too. And I think that kind of a convergence or consilience of approaches is what makes science so strong. I get really excited about how the processes of science are much more diverse than students are typically led to believe. So I make an analogy to music too. Like when people say that they don't like science, to me, that's like somebody saying they don't like music. There are people who maybe just don't like to listen to music, period. But I think they are a very, very small minority, and most people like some kind of music or other. They don't like the same kinds of music. They may hate what I love and vice versa, but it would be weird to say they just hate music or they don't like music. And to me, that's what saying somebody doesn't like science is, because there are so many different kinds of science. There are so many different forms, styles, approaches. And so I think everybody likes science. They just have to figure out what kind of science they like. Coming back around to Matt's question, I would say something that has the most potential for impact, and it's new, is the Sci Journeys unit that I actually worked with Matt to launch. And that was originally envisioned as a unit that he would build where a lesson would be built around each of the verbing science videos. And what we ended up doing was something so much bigger and more awesome than I could have imagined, which was we created a unit and really a template for a way of thinking about science as this collection of sort of worlds that different scientists navigate differently. We put communicate right in the center. And so that is something that is not typically shown in the scientific method. But we also have other more familiar steps like asking questions, collecting data, analyzing data, interpreting data, actually inviting scientists to submit their sci journey to this competition. I think that this is going to be such a powerful opportunity to really show students all the different ways that science can look by saying how it looks for you and using our world map, our sci journeys world map to say, okay, well, I actually don't make hypotheses first because I'm doing more descriptive research. So I actually start with collecting data and I know kind of the general data that I want. And then I get some of this data and it gives me an idea for a good question. But I have to communicate in between. I have to talk to my team members about the data too before I know what kind of question I want to ask, that kind of thing. And we have some great example videos that Matt and one of his other colleagues put together just to kind of give people a flavor of how to do it. It's pretty unusual for folks to be able to have a SciComm award to put on their CV. There aren't a lot of them out there, so that's one of the perks. And we have cash prizes as well for the top 3 finishers. But the big exciting reward, in addition to those personal accolades, is contributing to this repository of videos that we hope will then go to classrooms everywhere and really help more students understand what authentic science really looks like and hopefully see themselves in science, figure out what kind of science they like instead of saying, I don't like science. So that's this project that I'm super excited about because it really brings together a lot of the threads of my experience. I hope will be an impactful format for students. In terms of the most rewarding, I would say the work with middle school students has actually been the most rewarding because I get that immediate feedback. I'm glad that I'm doing things that are a bit more broadly focused, that I'm creating things that can be implemented and used in a variety of settings because I know that that's going to enhance my impact in terms of the number of people that I can reach. But there's nothing like the depth of those one-on-one relationships to really let you know that you've done a good job. I mentioned the student that I worked with from 2nd grade who recently graduated from Stanford. And we did a fun thing. It was fun, but it was also like a secret test. Our mentoring crew, our cohort, that I instilled after realizing that a lot of students, including students who are really, really good at math, would absolutely panic and forget everything they ever knew when they saw a fraction. Maybe some of you listening have experienced this as teachers or as parents, but that somebody could understand how to solve an algebraic equation perfectly. Then one of the coefficients is now like 2/3, and all of a sudden the world has ended and we don't know what to do anymore because they just didn't quite get proficient at, or they got proficient at it but then they forgot about it. Again, it's why I think I spend a lot of time thinking and working with them about like, why is multiplying by the reciprocal the same as dividing? That's just a thing that you learned that you did, but why does it work that way? And so we instigated Fraction Fu Friday, and we had different belts and they each had little sensei paper dolls that they would add their belts to as they earned them. And it was always a timed thing because I wanted them to be really, really proficient. So it was a really high standard because, as I always told them, this is not about being good at fractions. This is about being a fraction ninja. Like, I want you to be able to do it in your sleep. But on the other hand, there was no pressure because there was not a grade. There was lots and lots of chances. And so the student who recently graduated from Stanford wrote me this wonderful letter reflecting on our experience together. He talked about how that was so good for him because it really helped him navigate the frustration of not getting everything right the first time, and his natural tendency toward perfectionism made him see that it's not going to all end if I don't do this. The standard is high, but it's okay. You can take as long as you need to meet it, and I'm going to help you, and we're going to do it together. That has increased his resilience so much in other areas of his life and in his academic work. It was exactly what he needed. How often does any teacher get to not only see and know privately that they had the exact impact that they were trying to have on somebody, but then have the student tell them, not just you had an impact on me, but this impacted me in this way, and it was exactly what I hoped would happen. I think that story really illustrates the rewardingness of those kind of one-on-one relationships.
It makes a lot of sense to me because if we're thinking about the scale of our impact, that tends to be bigger but more shallow. But if we're thinking about the depth of our impact, that tends to be fewer people but more time and more investment and connection. Valeria de la Rosa Reyes is our next guest for next week. I am so excited to talk to Valeria. We did the Linton Poudry Leadership Institute with Sackness together over the summer, and I think she's going to be a really wonderful guest. I'd love to know, what is your question for Valeria?
I was reading a little bit about Valeria, and it seems like she places a really high value on mentoring in a lot of different contexts and at a lot of different levels. I just would be interested to hear about a particularly impactful mentoring experience that she had. And it could be that it was a really good mentor that she had that made her then want to go out and be a good mentor to others, or it could be like a really negative experience that made her think, you know what, I'm not going to do that. I'm going to do this differently. But just something that a mentoring experience that impacted her.
Jocelyn, thank you so much for being on the podcast today. It was a pleasure to talk to you.
Thank you so much, Vanessa, for having this wonderful conversation and for being my new best friend.